everyone, and welcome. So you probably know about linked lists, right? Well, today we're going to give that classic data structure a serious upgrade. We're diving into the doubly linked list, and you're about to see why its two-way street approach is such a game changer. Okay, let's get right into it. But first, just a quick question for you. Imagine your data is like a train on a track that only goes one way. If you miss your stop, what can you do? You can't just go in reverse. You'd have to go all the way to the end of the line and start over. Sounds like a total pain, right? Well, that's the exact problem we're about to solve today. Because that train on a one-way track, that's basically a singly linked list. Each little piece of data, we call it a node, only knows about the next node in the chain. So node 10 points to 20, and 20 points to 30. But 30, it has absolutely no idea that 20 even exists. It's a one-way street, pure and simple. And that brings us right to the heart of the matter. This forward-only design has a pretty big limitation. Sure, it's simple, but it creates a real bottleneck when we need to start messing with our list. This right here nails the problem. Let's say we want to get rid of node 20. Easy, right? Well, to do that, we actually need to tell node 10 to skip over 20 and point directly to 30. But if all we have is node 20, how on earth do we get back to node 10? We can't. We're forced to go all the way back to the beginning of the list and walk all the way down just to find the node that comes before the one we wanted to read. So how do we fix this mess? The solution is actually beautiful. What if every node didn't just look forward, but could also look backward? What if we just gave every single node its own little rearview mirror? And that, my friends, is a doubly linked list. Each node is just a little bit smarter. It's still got its data, and it still knows what's next, but now it has this crucial third piece, a prev pointer, that links it back to whatever came before. That's the secret sauce. And check this out. This is the new reality. It's not a one-way street anymore. It's a full-blown superhighway with traffic flowing in both directions. Node 20 knows about 30, and now it also knows about 10. Every single link in the chain is connected forwards and backwards. This gives us incredible new flexibility. And all this new flexibility, it's not just a cool party trick. It gives us what I like to call a deletion superpower. Remember that clunky, slow process we just talked about? Well, let's see how our new two-way street just completely blows it out of the water. First, just a quick reminder of the old way. With a singly linked list, if you want to delete a node, you have to start at the very beginning, walk all the way down the list to find the one before your target, and then you can finally do the surgery to cut it out. It works, sure, but it's slow. Now, look at this. What a difference. With a doubly linked list, we go straight to the node we want to delete. And from there, we have everything we need. We just use its prev pointer to find node 10 and say, hey, your new next is my next. Then we use its next pointer to find node 30 and say, and your new prev is my prev. And that's it. No traveling from the start. It's direct, it's clean, and it is so much more efficient. And this awesome two-way logic, it applies to everything, not just getting rid of nodes. So let's take a quick look at how it works when we want to add a new node right into the middle of our list. All right, so we want to slip this new node, 25, right in between 20 and 30. Think of it like weaving a new link into a metal chain. It's just a few pointer adjustments. First, we tell our new node, 25, okay, your prev is 20 and your next is 30. Then we have to tell its new neighbors about it. We tell 20, hey, your next isn't 30 anymore, it's 25. And we tell 30, your prev is now 25. The chain is reconnected, perfectly seamless. Okay, we've seen the idea, we've seen the diagrams. Now, let's take a quick peek at how this elegant concept actually turns into code. We're just going to look at the basic blueprint for a node in a couple of popular languages. We'll compare C++ and Python, but really don't worry about the specific syntax here. The key thing to notice is that the core idea, the structure of the node itself, is pretty much identical, no matter what language you're using. So here in C++, we define a struct called node. And look what's inside. It's exactly what we've been talking about this whole time. You've got your data, and then you've got two pointers, one for next and one for prev. It's a perfect one-to-one translation of our drawing. And now let's hop over to Python. It's a class instead of a struct, but the guts are exactly the same. When we create a new node, it's got a spot for data, an attribute for next, and an attribute for prev. See? The blueprint is totally universal. And this is where it all clicks into place. These two simple lines of code are the engine behind that super efficient deletion we were so excited about. The first line tells the node behind us to point to the node ahead of us. The second line tells the node ahead of us to point to the node behind us. It's that beautiful two-way handshake right there in code. So doubly linked lists seem pretty amazing, right? They're flexible, they're efficient, so why wouldn't we just use them all the time for everything? Well, like any good engineering choice, it all comes down to a trade-off. Let's break it down real simple. A singly linked list, it can only go forward, which makes deletion inefficient. But a doubly linked list lets you cruise in both directions, making that same deletion super efficient. But, and here's the catch, there's a price. Every single node needs a little extra memory to store that prev pointer. So really, we're trading a bit of memory for a whole lot of flexibility. And honestly, this quote sums it all up perfectly. That extra pointer for prev might seem like a small thing, but the power it gives you is absolutely massive. It fundamentally changes how you can work with your data, making complex stuff suddenly feel simple and fast. Which leaves us with one last thing to think about. I mean, we live in a time where computer memory is cheaper and more available than ever before. So, is there really still a place for the old school, one-way, singly linked list? Or has the power of the two-way street made it pretty much obsolete? Something to chew on next time you're building something. Thanks for watching.